Hello, let's continue our Sudoku adventure with What Remains Between by ChinStrap. So this continues our entropic-like line theme, and for whatever reason, so far everyone has picked modular lines, but there are other ones coming up, I promise. But you know, we're getting our practice in with modular lines here. So let's go over the rules. We have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. The one line in the grid is a single long modular line made up of 5 separate between lines. So we've got one long modular line like that, and then the circles give us between lines. That's a between line, that's a between line, that's one, and that's one. Just to be clear about visuals. Kind of nice to specify that when it could be unclear. Just sticking that in the rules really helps. All right, so between lines. How do between lines work? Well, we've got two circles separated by a line. Whatever digits go in the circles, say this was 2 and this was 5, these digits have to be strictly in between the 2 and 5. So even if we didn't have the box restriction here, these could not be 2, 5. They also can't be 1, 6 because 1 is not between 2 and 5. So we'd have to put 3 and 4 in here in some way. Those are the only twos available that are between 2 and 5. So this would be one way to fulfill this between line if we ignore all the other rules. All right. We also have one long modular line. So pick any set of 3 cells that are adjacent on the line, like these 3, these 3, these 3, any set of 3. Every single one of them, however you can do a set of 3 adjacent, have one of each of the groups 1, 4, 2, 5, and 3, 6. Now each of those groups are defined by their remainder after dividing by 3. So 1 and 4 have remainder 1, 2 and 5 have remainder 2, 3 and 6 have remainder 0. But you can also just treat them as groups if you'd like. And so we have one of each of the 3 groups. So if this was a 1, that uses up both the 1 and the 4. So we can't put another 1 and we can't put another 4 within this group of 3. We need to get a 2, a 5, and we need to get a 3, 6. So maybe this could be a 5, and then that gives us the 2, 5 group, and then this could be a 3. So we have one of each group. The 1, 4 group, the 2, 5 group, and 3, 6 group. The order doesn't matter. We can switch these around, but as long as these 3 have that, that's true. Remember, that also has to be true of every group of 3 on the line, including all these overlapping ones. All right. And we have a singular V here. Those two sum to 5. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay. How do we want to get started? I think I want to color first. So what have I done here? Well, this group of 3 here has one of each of the modular groups, and I'm going to color them. I'm going to say whatever this one ends up being, that's our green group. This is our purple group. This is our orange group. Now, this group of 3 also needs one of each, but it already has a purple and an orange, so the only choice is for this to be green. And that's just going to be cyclical, because these 3 now need a purple, and these 3 now need an orange. So we're just going to go green, purple, orange, green, purple, orange, green, purple, and we're done. So that is the groups, but we don't know what color is what group. We do know that there are 2 of each color in every row, column, and box. So for example, we already have 2 greens in this box. We can't put more greens in the box. So these greens have to be pretty far away from each other, although they're all the same amount away from each other. 1, 4 would put a 2, 3 up here. 2, 5 would put a 3, 4 up here. And 3, 6 would put a 4, 5 up here. So, that's very tight, though. Might as well put 1, 2, 3, 4 here. I don't know how much that helps. Is there any coloring I can do that I didn't notice? It's mostly that we have a lot of greens used up. This is the same. So whatever these 2 digits are, it's the same as these 2 digits. Because this is 2 greens, this is 2 greens. This is a green and an orange. This is 2 oranges, so these 2 are between. What do I do with this information? This digit here is not all. Okay, I guess one thing we can say is on every line, not counting the circles, on every line we can only put. We can't put 1 or 6, right? Because we can't be extreme around 1, 6. So they're from 2, 3, 4, 5. Does that help me, though? 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 I'm not sure that it helps me. So these two are the same digit because, you know, this is the other one, right? Just through that. These can't be the same digit or you'd have nothing but a between line. So these have to be different. That's kind of the point. Do I want to flash these maybe? So I guess I'll give this a red flash here, red flash here, and then this can be have a blue flash. So this is the red green and this is the blue green. So this is our red green and this is our blue green just by Sudoku. I can do the same for these. We know these are the same as each other because they're between the two greens. There's only 2 digits between the 2 greens, no matter what the greens are. So all of these I can just give, say, the red flash to. So this is the red orange and this is the red purple. The question is, can I continue that? We know these 2 oranges are the same. Are they restricted on which orange they are? Kind of. Yeah, I mean, this has to be the red orange. So we have a purple and an orange and a green here. We have a purple and orange and a green here. By roping, these have to be the same digit. So these are all red flashed. So this is the red orange. So this then has to be the blue orange. Okay. So between red orange and blue orange, we've got this purple. It could be the same purple as this one, though. It probably is. Is there a way to prove that it is? I can't think about that right. Maybe we don't have to think about that yet. Is there more I can do here then? So we know that we need the other purple and orange here, and they're the blue version. And then up here we need so these are all blue and these are all blue, I guess. But there are 3 blues and 3 reds in every row column and box. So these are all our blues. Actually, in fact, there's only 1 blue left that can go here. It's the blue purple. There we go. And so this is the red purple. And then this has to be the red orange. Okay, this is interesting. So here we need the orange and green. How do I continue this? I don't know what's going on here. How do I get digits? That's the question. Oh, I have 3 reds here, so these are all blue. Are we restricted on what blues they can be? Doesn't look like it. Well, this can't be the green, but either of these could be. I've got a red green down here. So this green has to go down here somewhere, but these aren't green. So this is our red green. So red green's one of these. I'd really love to have both reds or something, but do I need to think about this outie here? This circle? So we know this one's not 1 or 6. So it's... We need a 1, 6. We need a 1. We need a 5 and a 6 in here somewhere. It's kind of what this 1, 2, 3, 4. I'm trying to think what it does. Like the row, or do I need to do more here? So I wonder if we could have split between lows and highs. I'm tempted to redo the flashes. Like, okay, so we know that red, blue, we don't know if red is low or high, but we know blue is the other one, right? And so in between them, we're going to have 2 digits. They're either 2, 3, 3, 4, or 4, 5. The problem is I don't know whether those are low or high or not. But these are the orange and the purple that go between the two greens. So does that mean this purple has to be blue? Because if this purple is in between both greens, can this purple then be... Let's put some solid numbers on it, because I don't think it matters what numbers we pick. So this isn't the answer, probably, but let's say this was the 1 and this was the 4. That would make this a 2-3 pair. And so the question I have here is then, this is definitely the 4. Can this be the 2-3 was my question. I think it can be. Because the orange could be, for example, a 6. Okay, so I don't think we can do it that way. I wonder if it has to do with 1 and 6, then, or 6 and specifically. So we know none of these are 6. So what does that leave? Only one option for 6? So red, purple, and red, orange are not 6. And red, green is not 6. So 6 is not red. 6 is blue. So which blues are on here? So 6 cannot be green. So green is definitely not 3-6. So 6 is either blue-orange or blue-purple. 6 is blue-orange or blue-purple. How do I prove which one? So, okay, so why don't we look at all the greens here? And we know that they are not 3-6. So they are 1-4 or 2-5. But we also know that green blue cannot be 1, which means green red cannot be 4. Because, you know, if green red were 4, then green blue would be 1. Now, we narrow this down further, or... Five with 2 here. 2, 5 with 3. So that means there is always a 3 on here. Because these are not the 3-6. So yeah, that, I mean... Okay, and we know... Okay. So what I'm saying here is that 1-4 would cause a 2-3 pair. And the other option is 2-5, which would cause a 3-4 pair. So these are from 2, 3, 4, and there's always a 3 involved. So all of our purple and orange reds, so all of our reds that are purple or orange, are from 2, 3, 4 only. That joins this. We only have 1, 2, 3, 4 left here. Same thing for this row. Okay. Yeah, we knew red omitted 6. That confirms it. This being 2, 3, 4. I don't think... can it be 3? Oh, it can be. Can it be 4? 4 goes with 1. So this would be 2. That would be 3. Unfortunately, it's kind of working out. But these only have 1 in between them, which is kind of my issue. So we know 6 is one of these two. 6 in this column. Do I want to think about this guy yet? Problem is, I don't know much about this. We know 2, 3, 2, 4, or 5 is in the middle of it, but that doesn't really help me too much. No more greens in this row. Oh. This is not. So we have this blue we have this blue green here and this blue green here. So one of these two is the blue green digit, but I don't know what to do with that. Huh. We also need one of these to be green. Is there more that I've kind of just missed here? It's got to have to do with this V. These are both orange. So these have to be Oh, right. Sorry, first of all, we can't put a 1 on this line. I missed that red-green isn't 1. Ooh, I totally missed that. Whoops. So it's down to 2, 5, which are in the same group. Well, that would make things easier. So green is 2, 5. Okay. Which means anything not green is not 2, 5. All right. There we go. We got a lot of 3, 4 pairs here. 3, 4, 2, 5. So these are 1, 6. And this can't be a 1. No, it's in a circle. It can be a 1. Whoops. I get the feeling this V is going to force this to be 6, but that's just a feeling. I don't know how it's going to work. This purple, unfortunately, this works as purple red, I think. This works as the purple red. In fact, I don't know what I'm saying here. This was purple blue. Be 1, 6. I don't know what I'm saying here. How do I get more here? 3, 4 pair in here. Does this 2, 5 pair do anything for us? These can't be the green 2, 5. So these are, because it sees the red and the blue 2, 5. So they're not 2, 5. So they're 1, 3, 4, 6. Oh, and they're not 3, 4 either. So this is a 1, 6 pair. And that makes this the green 2, 5. The green blue 2, 5. Oh, the green red 2, 5, sorry. I did that wrong for the column. Ooh, we knew that already. These looked in. Shoot. Okay. I could have had that. So that's all our reds. These are blue. That's all our blues. So these are red. That's all our reds. So these are both blue. Oh, we knew 1, 6 was blue. So the other blue is the green 2, 5. All right. So this is 1, 6 blue. We already have the green 2, 5, so this is 1, 6. What do I do about this purple? I want to give it a flash, but let's see. This we have 1, 6, we have 2, 5. So we need 3, 4 here. And this can't be the orange 3, 4. So this is the purple 3, 4, and this is the orange 3, 4. So this has to be purple. This purple ends up here. And that leaves this to be the orange. And so then this purple does have to be blue. This is a purple blue, 1, 6. So 1, 6 pair on circles doesn't do much for us, but there it is. These are these digits. The orange 1, 6 and the red 3, 4. So the red 3, 4 can only go here. So this one, and so then this is the 1, 6. Getting there. So then this is the orange 1, 6, and then this is the red 3. It's not 3, 4, is it? The red blue. What is red blue? No, red blue isn't a thing. Sorry. It's the green. It's the green blue. Red blue is not a thing. It's the green blue 2, 5. Okay. So 2, 5 pair does remove 2 from here. It removes 3 from here. Oh, we have the 3, 4 pair. It removes 4 from there. Which removes 1 from there. Oh, 1, 6 pair removes 1. So this is 2 and this is 3 to add to 5. So that gives us a lot of digits. So we know that the red 3, 4 sorry, the purple 3-4. The purple 3-4 is actually a 4, which means that the blue 3-4 is actually a 1. Which means the blue-orange is a 6. The red-orange is a 3. And the red-green is a 5. And the blue-green is a 2. So this is blue-green. And 3 is red-orange. So this has to be purple. At this point, normally I just clear all the colors, but I'm so close to having them all colored, I just kind of want to do it. So this digit's a 1. So this is 6, 1, and 6. So this has to be purple, and these two have to be orange. And then this is green, which makes it a 2. Let's see. We need a blue and a red here. And then this needs to be purple, and this needs to be green. And so taking longer just to get the colors than to type numbers in, but I kind of want to finish this. This is our 5. All right. I probably have some coloring wrong here that's going to annoy everybody, but it's not on purpose, I promise. All right, cool puzzles, ChinStrap. I wonder how much I missed that I could have resolved this much more earlier, but it was kind of neat to just resolve it right at the end there. All right, cool. Well, let me know how you did. If you enjoyed this, why don't leave a like, subscribe, and a kind comment below.